Yeah. And I know that Christian had planned on joining, so maybe I'll leave a message in the Discord just to let him know that we're here.
Okay, cool. Chris, who did you say? Christian?
Yeah. At least earlier in the week, he'd mentioned that he would join this session.
Okay, sweet. Maybe we can do a quick round of introductions then while we wait for Christian, just since we have, I don't think, well, we haven't all been in the same room together. So just, yeah, I guess very briefly, so I'm Richard, my background's in machine learning, and just to give a bit of history of the DeFi hacking session, it was, I did kernel with Greg and Christian, and that's where we started chatting and came up with this idea for working on some data science models for financial data. And so, yeah, just like bringing together the domain experts in financial data with like data scientists, that's one of the main things that we want to do with Algovera. And so that's why I really like this series of hacking sessions. So yeah, maybe I'll pass to Keaton really quickly.
Hey folks, good to get everyone in a room. Vintage, good to put a face to the name. Yeah, I'm Keaton. I joined the core team last year in December. I have a background in operations working for ActBlue, which is a tech company here in the US, as well as some blockchain development experience. So focusing on our development sprints for these next couple weeks and months. Huge shout out to Jakub, who is crushing everything in that regard. But yeah, excited to get hacking on some DeFi data sets.
Who do you want to pass to?
Might as well pass to Jakub.
Hi, everyone. I'm Jakub. I study maths and physics. I'm also an Open Web Fellow at Absentia, where I'm researching like open science communities and general token engineering for decentralized science. I've also been getting involved more and more with Algovera. And I'm currently working on a Jupyter Lab extension that incorporates MetaMask with Ocean to sort of smooth out the process of interacting with Ocean for data scientists. So yeah, I guess I'll pass it on to Greg.
Great. Hello, I'm Greg, co-founder of Window Finance. Met Richard and Christian, who's not here as well during kernel. Amazing program. So serial founder. Window is a new venture that I'm putting on together, building with Iago and many more new people. Basically, our objective is to help investors discover, demystify, and de-risk investment opportunities, DeFi investment opportunities, using information and data. So I am always the dumbest guy in the room, especially when it comes to data science. So I'm more here to maybe provide a business angle rather than go deep into Jupyter notebooks. But who knows? In a few months, maybe I'll be there with you. And I'll
hugely valuable.
I'll pass it to Vintage Gold then.
Hi, so my name is Vintage Gold. So I've been doing data science for around a year now. I started in financial accounting systems, configuring Oracle accounting systems, and then I moved on to, I got involved in like BI dashboards, and then I said, that's really cool, and then dove into data science and got my master's in that. And how I found out about Algovera was there was a bounty, and then I joined the Discord, and just everyone started talking, and it was a really nice community. So that's where we are today.
I guess that there's only me left. I'm Iago. I am an electrical engineering undergrad, but I've been more focused on data science recently. I've honestly a beginner in this field. I'm just learning, and I'm working with Greg on the Window Finance project. So we're on this together. As you saw, he's a very humble guy, but we're hoping to contribute a lot to this project and to Algovera.
Great. And Christian just got here. Hello.
Hey. How's it going?
Good. Great. Just finishing up a round of intros. I don't know if you wanted to give a quick overview.
Yeah, for sure. So yeah, my name is Christian. I'm, I guess, been in the Algovera community since almost day one. Started with these DeFi hacking sessions, which have been great. Aside from that, I'm working on a company called Component, which is focused specifically on data within DeFi, really. So we are trying to essentially reduce information asymmetry in DeFi, by building out kind of a new layer of trusted data, and making that available to the ecosystem. That amongst a couple other things, we also built simulation and optimization tooling on top of other protocols. So yeah, I've been pretty much just doing that full time for the last 4 months. So I think very fitting for these types of sessions going forward and working with Algovera in window finance.
Great. Yeah, cool. So great to get the introductions. I guess Vintage Gold, over to you to show us your work, just to get up to speed with where we were last year, and then maybe we can talk about some next steps and things like that.
Yeah, sure. I will share the screen. Okay. So I looked at the last DeFi hacking session, and I saw that we were using these two data sets. So one's from Compound, one's from Aave. I don't know who put that in Discord, but thank you for those data sets. So then the goal was to kind of understand what's happening in the data set. So let me just delete this. So if we read in the data sets, so do this, we can see that there are 4 different types of currencies or tokens. And so this is what our data set looks like. So everything has a timestamp. So it seems to be that there are it's every 30 minutes. This is an interval. And then we're trying to predict the borrowing rate. So then if we look at just the different behaviors between the different tokens, we can see that DAI has some volatility to its borrowing rate. So it's going to cost more to borrow DAI in this case. Same with USDT and USDC, and then USDT is a pretty interesting one. It seems to always be volatile. There always seems to be a short supply of it. That's what that would tell me. So there's definitely an application for trying to, if you're borrowing debt, you want the lowest borrowing rate. So being able to swap out your wherever you're borrowing against, that would be helpful.
One quick comment is one thing that's missing in this data set, which might affect this, is the actual, this is for Aave, right? This one?
This is for Compound.
Okay, for Compound. Well, one thing that we're missing for Aave and Compound is for Aave, the incentive APY for each market, and for Compound, the distribution APY, which is basically an equivalent to the incentive APY, which can technically, depending on the size of it, offset the cost of borrowing, because you're basically getting an incentive just for using that market. Not to take away from the analysis at all, because it's super important, but once we add that in, I think that'll also add some color as well.
Yeah, but I also think that those incentives are usually driven by the protocol itself. And for example, Aave gives out their rewards weekly. And I think the borrowing rates itself is just driven by the market. So I would say it's easier to predict these interest rates than take into account the rewards as well. So I think it's a good start to only look at the interest ones, because it's the one that it's market driven.
Yeah, for sure. I think it's super valuable either way.
So on Aave, did they have I know there are incentives for going to Polygon. Are there also incentives for just using Aave regularly?
Yeah,
just
so almost
it's in the Aave token instead of Polygon, I guess.
exactly.
Yep.
Yeah.
Okay. Cool. Yeah, that would be an interesting thing to look at. So then just looking at like the correlation between just at an aggregate level and not by token. So we have like a really high deposit rate correlation with the borrowing rate. So the more that the deposit is, the higher the borrowing rate is going to be, which I thought seems like it should be the opposite. Because then you would, like, the higher the deposit is, you would have more supply. So that would make it the borrowing rate go down. But the correlation is telling me the opposite. This also, just having this high of a correlation, regardless of whether it's negative or positive, kind of hints at that just looking at the entire data set, that there's some deterministic thing that's happening, whether it's a calculation, but it could also be the scope of how we're looking at the data set. Maybe windowing would change this correlation. Any thoughts on that?
You have to think that in order to borrow, you have to deposit because it's a over collateralized loan. So it makes sense that, because I think like those rates are driven by the volume of borrowing and depositing. And once the depositing is going up, the borrowing volume will also go up because people are probably depositing in order to borrow. So I think that kind of makes sense. That is a very, very high correlation number though.
So then,
This is the first time I've looked at this. Just a quick question. So these are the deposit and borrowing rates for the same token, the same, for example, USDC, or this is just the protocol in general?
this would be the protocol. This would be regarding these 4 tokens, and then taking the entire correlation of all of the different borrowing rates.
Got it. Yeah.
So for like
Because, I mean,
so basically for every line, so every time stamp, every 30-second interval for each one of these, you would say that they all have the same behavior because there's such a high correlation.
Got it. Okay, thanks.
Mm-hmm. So then I just wanted to kind of test out like what the flow would be for, an ML problem like this. If you were to, instead of doing windowing, you kind of just looked at the data set and you said, what could I do if I just took like any data point and tried to predict another data point? So the first step was like taking out 10% for like the final test of the model. Then I just take like the last 10% so that there's some time availability there just in the testing set. And then I just create a label so now that the tokens, let's do.
Can I just clarify something there, just for people who aren't in machine learning? Maybe people haven't heard about like training set and validation set and test set. And the idea, so the reason we want a training set and a test set is because you don't want to, if you train an algorithm on data and then you test on that data, your algorithm might have just memorized the data. And so we want to see how well it generalizes to a test set that we withhold, basically. And then sometimes people split that into like more than one test set. So it's kind of like a training, validation, and test set. And so the idea there is, maybe I wonder, we basically, for every pass that we go through the data, we test on the validation set. And then at the very end, we withhold another test set that's only used at the very end. So like, that's a bit more complicated, but it's a similar idea. We always want to test on data that we haven't seen before, basically.
Yep.
Also,
into-
oh, sorry, I was going to comment on what you said earlier, which was the high correlation between the borrow rate and the supply rate for Compound. So something I posted a while back, although it was kind of buried in a link, is a formula that I can send, which is basically that like the supply interest rate is actually like one of the variables that determines that is the borrowing interest rate. So as you were saying, like it actually is like the borrow interest rate is like a function of the borrowing interest rate. The supply interest rate is a function of the borrowing interest rate. So that would make sense.
So then I apply a label encoder to the token so that each line still has ingrained in it what the token is. So that way you're able to kind of see if behavior between tokens is related to one another. And then there's just another correlation plot.
Just to add to that as well, so if we have a categorical label, which in this case is like the type of coin, if you want to do machine learning on it, you usually just change it to an index like 0, 1, 2, 3, and it just makes it work in the machine learning models, I suppose, instead of using strings like DAI and USDC and ETH and stuff.
Yeah, it needs to only be fed numbers. Soon it will be able to feed it English.
Yeah.
So then we end up going into it, kind of talk about how it's baked in. That's the contract. If anyone wants to read some Solidity. Just looking at borrow rate over time again, and then it's just illustrating the 99% correlation between deposit and borrowing rate. So then, so now we have like the test and training sets for the data set and the target. So we're going to use like all of the columns besides borrowing rate and the string columns for the data set, and then for the target we're just going to use the borrowing rate. So then we're going to fix and transform the X. That was because I think not everything's on the same scale. That could probably be modified. I would have to double check if everything's on the same scale. So that would put everything between 0 and 1. And then just putting the just putting the labels back on the 0s and 1s here, and then we're splitting it to test train split. So we're splitting it 80% train, and then we're stratifying it so that the train and test data set have the same quantities of the different token labels. So you get a good representation of all tokens in the training and test data set. So then, just to validate that, because I don't think I've been running some of these cells. So there we go. So then just to show that like what the quantities are within each test and train. So that's 80%, 20%. Then I just use a simple linear regression model to fit, and that gets like a 99% of R squared. So that means that the test set could explain the target 99% or 99, which is extremely high. With like 0, that screams to me that there's that just doesn't happen. So then just kind of went into and did the same code, but then just tried different models. And it seems like, what did I do? Actually, what's the main difference? Oh, I just tried to do it without the deposit rate. So the feature that's not 99% correlated with borrowing rate, if I just remove that, what do I predict it with now? And so the linear regression goes way down, which makes sense. And same with the ridge and same with Bayesian ridge, because these are both linear models as well. So that makes sense that the high correlated feature being removed, that linear models would go down. However, a decision tree, so it's just making like one choice and one choice, kind of like a tree. So that ends up getting a 99%, which again seems very, with like no tuning, nothing, just gets 99%, seems way too good to be true. So there's something going on there's some other related feature that might just not be linear. But yeah, there's something going on. And then we just get to I was just messing around with this today, just how to window. So I think we can now start the discussion on different windowing and what window size we should try, what windowing strategies do we think is best?
Yeah, so just to explain that a bit, so like there's a couple of reasons it could have got really high accuracy, the way I see it. One of them is that like something is deterministic, and so it's like quite an easy function to figure out. And the second one is that, so the way that we chose the training set and test set was done randomly. And so if we had 100 time steps and we chose 10% test set, it would choose 10% of those time steps, but it would choose them randomly distributed within that 100. Does that make sense? And so like, it might be the case where one of the time steps in your test set, you actually have the time step before it and the time step after it, which makes it a really easy problem to figure out the test step, the time step in the middle. And so what might be more representative of our use case is if we just took the first 90% as the training set and then the last 10% as the test set. And so, yeah, that's more representative of what we would be trying to do in reality. And then also the windowing approach is where, maybe we actually have a big time series of like 1,000 time steps. And we just want to create these windows of 100 where the first 90% is train and the last 10% is test. And then we can kind of slide that window over the data and come up with lots of different, groups of 100 time steps that we can use to train the algorithm. And so there seems to be a few libraries that we can use to break up the time series like that as well. I came across one that I just linked in the group, and Jakob came across another. But what would be really cool would be if we could set this up, and if we still get the same 99% accuracy, then maybe there's then maybe it's something else. But I would guess that this would lower the accuracy by doing this quite a bit. And the other question was about is it deterministic? I was chatting about this with Vintage Gold, and so even if it is deterministic, it might be deterministic at a certain time step. So if we have all of the values at a certain time step, we might be able at T0, we might be able to predict the borrowing rate perfectly just using an equation, right? But it might be the case that actually we don't have all that information at the current time step because we're trying to predict it we're trying to predict it in the future. So we're at T-1 and we're trying to predict at T0. So even though it's deterministic at T0, we don't have any of the values at T0. And so it might be that it's a deterministic equation, but actually we don't have any of the inputs to that equation.
Yeah, that makes sense because I think all of these protocols are similar in a sense where it's calculation driven. So depending on the deposits, on the borrows, and then you plug those into the borrow rate interest model or like the deposit rate interest model, like they are actually deterministically correlated, or more than correlated, because almost like 100% correlation, because they're used to derive each other. That being said, so at T0, if you know the borrow rate, you know the deposit rate, basically. But like you said, what would be interesting to predict is like, can we identify a pattern such that we can figure out like what that might be at some time in the future, whether it's the next block, whether it's the next week. I'm not sure exactly what time frame we want to think about, but I think that's the interesting part for sure.
Exactly. Yeah.
I think one thing that could help us finding the pattern would be to compare this, let's say, this borrowing rate for Compound to the borrowing rate for Aave in the same time period, to see if they're somewhat correlated. Because if they are, then we could try to find this market pattern that are leading to people to borrow or more or less, and it could help us find the answer. Because I feel like just looking at Compound might not be enough, or just looking at Aave, whatever. So like, if we could take like the same steps that we took, analyzing the borrowing rate and the depositing rate from Compound and looking how correlated they are, if we could just do the same thing, but instead of using like the borrowing rate for Compound and then the borrowing rates for Aave, I think we could find some answers. What do you think, Christian?
Yeah, I think that'd be really cool. And I think also taking a step back, like around the deterministic aspect, although it's not as important in terms of like, I think what I'm trying to say is I think it's still important to understand the deterministic properties of each data set, because if we know, that like a very large deposit has this effect on the system, I think that's good to know. I don't know how much that will persuade the time series or like aid us in prediction, but I still think understanding like the data on a more granular level would help as well. But I agree, it'd be really cool to see the interplay between rates on two different protocols, especially ones that are similar size like this. And one thing in the future that I don't have a specific time frame for this, but hopefully soon, one thing that I'm doing a component right now is trying to standardize data for like protocols that are in similar categories. So for example, like we're almost done mapping data for 22 lending protocols, like on ETH-L1. So like, having like 22 subsets of data could add a lot to this as well, I think.
So that's like different lending platforms, 22 different lending platforms. Nice.
Yeah, but anything that has roughly greater than 50 mil TVL, we started with for lending. And then we're moving on to like yield aggregation and other stuff, but specifically in lending, there's 22. I mean, depending on the day, like how much TVL there is. But.
Christian, how granular is that data, and what's the kind of the window for which you got that data? Is it like way back since day one, or is it all recent?
So for our purposes, we're actually not recording historical data. That being said, you can query that, if you want to. Right now, I'm in the stage like with component of like evaluating the most like long-term, the best way to actually pull this data, like for as far as like latency. Like we're thinking about either the graph, actually like running our own indexer node on the graph so that we can ensure that the data is reliable. Two, just using like Infura, or three, running our own archive node. That being said, as I mentioned, like our purposes aren't necessarily historic initially, like we just want real-time data basically. But you can easily alter your queries to go as far back as really like the genesis of that protocol. The only issue is like you can't go that far back depending on the protocol, because like there's Compound v2, there's Aave v2, so it changes. But to answer your question, you can go back as far basically as like those protocols start.
Awesome, cool. yeah, share the progress on that, like for, you know, within this project and without out of this project. It's super interesting. I didn't even know 22 protocols just on layer one. That's nuts with that much TVL. It's crazy.
Yeah, I mean, it's fluctuating. I think it might be a little less than 50 mil TVL, but there's definitely more than I thought, because there's a lot of protocols that like do other things, but then they have a lending aspect, like the UIDX, for
Right.
example.
Right. Perfect. Cool.
But I really like a point that Christian made about the like how much a big deposit could drive those rates, because that seemed like a really cool simulation to do, and it could be really useful for big investors. You know, like I'm investing in this protocol, I'm going to put a lot of money in there. So why will my investment change in that pool? Like if we could use a deterministic model to tell him that, it could have very good. It could be super helpful.
Yeah, like one interesting thing about compound that I found out when looking into like, you know, uh, the deterministic formulas, I guess, is that there's like 16 interest rate models that are being used right now, and they actually vary based on the pool, so like the underlying asset, the underlying token. So like understanding even those interest rate models, you get a better understanding maybe of like why things fluctuate the way they do. Then there's a whole other area of data which you know, I'd love to get my hands on, and that's like governance data, because you know, one huge aspect of like if we're thinking about alpha in general, right? This area of alpha that we're looking at right now, I think is like even just forgetting the predictive aspect is like the, you know, like analytical alpha, understanding the data and like the deterministic calculations that are of the system, I think is like a form of alpha that not many people even get their hands on unless they're like a quant fund and that's their job. But another area is like governance alpha, which is like, you know, if you know that like a governance proposal is going is being voted on and might go through, the changes rewards rates significantly. Like that's a huge form of alpha as well. Being able to predict, there's actually a couple companies that I think are doing this for other protocols, but like if you can kind of simulate or predict how like a governance proposal might change the future version of that protocol, that's like really cool alpha as well. And I know that's like a lot further down the road, like we would need data on that, but just like an interesting thought.
Yeah, I also think in order to get a better result of this, we should probably like maybe choose a token to look closer, because I feel like just looking at a big data set with different tokens, it's kind of hard to find out what's happening. And for stablecoin specifically, me and Greg were talking to a coworker of ours, and he actually had a pretty good point on this, that whenever the market is pretty hot, people will often deposit, let's say, Bitcoin or Ethereum into these protocols in order to use it as collateral to borrow dollars to buy more Bitcoin or Ethereum. So these rates should be also be a little bit driven by how bullish people are about the market and how much they're expecting to grow. Of course, all of this is very hard to predict, but it is something that we could take into consideration.
Yeah, I really want to know the USDT. Like, I just I've used Instadapp before. For those who don't know, they have like different strategies that you can do. So you can like swap your collateral. You can so you can get like a better supply rate, or you could swap your debt so you get a lower borrowing rate. So I was doing that manually, and because I would see like USDT would like jump for supply rate like 30%, like 30% APY, and then its borrowing would also could like supply would always shoot up, borrowing would just also shoot up. So trying to like manually time that, I was checking it like every day and just like swapping my collateral. So if there was a way to like predict that, and then kind of be like, hey, like in 3 days you might want to move your collateral over to this is going to look like it's going to have a higher supply rate, or you know, the inverse, there's going to be a high borrowing rate for this asset because it's going really fast. Instead of kind of getting like hit, just square in the face with those high borrowing rates. But one question for this, the intervals, is this what the data gives us, or is this how often compounds rates change? Is it like real time that it changes, does the calculation?
Not really. I actually just got I was the one that got this data set, and I just got every 30 minutes because they don't give you a time window. So I just chose a random one that was small enough to get a big data set, and yeah, it was just a random choice that I did, but it has no a particular reason whatsoever. But the one that Christian got for Aave, I believe it's block by block, so it should be a more complete data set than the compound one.
Yeah,
Yes,
and
this one.
to answer your second question, which is, so yeah, Aave, I think I did a block by block, so like the windows will vary, but that doesn't necessarily mean that the rate changes every block, because I think it depends on what transactions essentially are mined in that block with relation to like something that would change, like the borrow rate or the supply rate. So you might find like some blocks where it doesn't change, but I think a lot of the time it does.
Vintage, do you think it's quick to run a quick analysis on like how correlated are the borrowing rates from Aave and compound? Maybe
Dude,
just plotting both like side by side would be already a good start.
Sure.
Would you have to like join them on like if it was block by block, then you could join them on the time, right?
Yeah.
Like
one thing
because
is
30 minutes versus block.
Yeah.
I guess you could like force them to be in the same time period by maybe grouping by day or hour or something. There is a function of the data frames called resample, should be useful for that. You can like resample your time series as this one.
And what would the rule be?
Sorry?
It says rule. I just don't.
I think like if you type in
I
a
need
string
the
with
PD.
W, it would be weekly, D would be daily, H would be hourly, and
Oh, it's a
I
data
think
frame.
I
It
think
is a data frame thing.
you're doing it right. Would be Aave.resample, yeah.
Okay. And you could just do daily.
Yeah.
Let's see how this works. Help me. I'm delta string.
I think the data frame index should be a time series. You know what I mean? Because like
Gotcha.
either a date time index or
Let's do this. Time. Always forget this function.
this one. Yeah, exactly.
Then resample.
I think you have to set this datetime as the index.
Okay.
I think it resamples using the index. Yes. Yes. It's similar to the group by function. You kind of have to set it up like whether it's going to be the average of the day, the sum, or yeah.
Then I made it all 0 times. Is that how it was before? Why did it remove those?
Well, since it's
Okay.
one by day, I guess it doesn't matter like which hour is it.
Yeah. I guess we can do the same. So we'll just do. What would you suggest next? Because we just need to get these to be the same.
Yeah.
Oh, so then I could just do the same thing, right? Just on this.
Yeah, on compound, yeah.
Yeah.
But you have to
I
make the
know.
same play with the yeah.
Yeah. That thing. It's at the index, right? What do I call it? Date. Everyone's waiting in anticipation for this. All right, cool. So now we have that. 314 versus 380. Okay. So now we'll just plot them, right?
Yeah, I
So
think so.
let's do. We were gonna do deposit rate.
I think the Aave data set doesn't have the deposit rate. I think it's just borrowing.
Oh, just borrow rate. Okay. Do that. They're not gonna have the thing. All right, let's just do. I just knew they're gonna have they have to have the same. This 314. Oh, it's because it's the index. All right, I'll just do this then. All right, here we go. Oh, it's already an average. I'm taking an average of an average.
Yeah, I guess it depends on yeah.
It's a little weird. So I guess we don't.
This is the Aave one, right?
Yeah.
I need to check like if it's actually the average, because I think I just named it that when I like queried it.
Okay.
Let me try and find where I did that.
Okay. So he's putting underscores in my column names. All right, cool. Now we'll just do, yeah, we can just throw that guy in there. Let's think. To list.
Oh, I actually think it's like the plt.plot instead of
Oh,
just
yeah, you're right.
PLT.
Yeah, you are right. Thank you.
Yeah, actually, I think I messed that up because originally this data set was by day. And so I was taking the average by day. But then for this purpose, I changed it to by block, but I left the average function in there. So I don't know if that messes it up or not. I posted the Dune query in the chat here, but just to keep in mind.
I guess it would take the average of a very small.
We'll take the average of like 1, right?
Yeah.
So like I don't think that would do anything. Yeah, it would just divide by 1, so it should be right.
Right.
Yeah, just double check. It's fine. It's not actually average.
I just need to figure out how to plot this. I'm blanking. Right? Don't I just need to put the X here and it's a range?
Yeah, it
So
seems like the Aave borrowing only has like one number.
Oh. Let's rerun that. That's great. There we go. Thank you.
Nice.
Yes, that's list of brand.
Nice.
I'm gonna make those both of them just the same. So we have, actually, I think maybe I can do it this way. I don't remember if in the different plots if it has to be the same or not. Compounding. Oh, they're not. Are they not decimals? They're 3.
Oh, it's already multiplied by 100.
Yeah. So I just need to multiply this, right? So,
Yeah.
okay.
Yeah, I multiplied by 100 in the query for Aave.
Cool. So I'll just do
Nice.
always forget the fig size stuff. Do you want to just look at it this way and I'll just zoom in? Sorry.
No problem.
Nice. Yeah, it looks like there might be a correlation, doesn't it?
Yeah.
Yeah, it's interesting. I mean, they're the two biggest borrowing protocols. So, and things like Instadap, DeFi Saver, I imagine, as you were saying, like might do rebalancing, right? So it might make sense that they're kind of in tune.
Yeah.
And
Just clear as well of how much more volatile the Aave rates are compared to compound.
we can see if we can put it on an actual score. If we do like create a data frame of them. Or actually, we could just do. There's got to be like a NumPy core, right? I just do it by 2 columns. Yeah.
Nice.
So if I just put I have a feeling they're gonna have to be the same size. But we'll see what happens.
They might be not,
Yeah, I wonder.
because they're both time series, so maybe they're, I don't know. That's it. Yeah, yeah.
No. Two. Getting that backward. No, that's right. Okay. That is right. So they're 39% correlated because the ones is when they're correlated with themselves.
Yeah.
So it's like moderately correlated from a number. Or at least I would have to actually double check if this is definitely looking linearly. I would have to guess. Yeah,
And I wonder,
yeah, so Pearson, so it's a linear correlation.
I wonder if we had them both by block, if there would be more of a correlation than just
There
like
might
the
be.
average for the day.
Yeah.
Yeah, it could be.
Or even using like median instead of mean. I don't know.
Yeah,
Well, I guess
try.
there's, yeah.
Yeah, the average of the day is probably not the best way to look at this.
Just because if there is an outlier, like it just might skew the data.
Yeah.
Yeah, let's just change it real quick. I'm gonna take a snapshot of what it looked like. It's 39% correlated, so that's 20%, so it went down.
Yeah, it goes down when you use the median.
That's
Did you
right.
multiply by 100 then? Or?
Yeah.
That's weird.
What did it change to though? 1.5.
This is the token labels. You probably when you do the resample function, you probably mess it up.
That was so I probably need to read the data. All right. That I'm not trying. Oh. Would that go down?
Weird. Anyway, I think we made some good progress on it, right?
Yeah.
Yeah.
So yeah, thanks
Well,
again for hacking on it, Vintage.
no problem. But you can see from this that the correlation went down, so the chart would follow suit.
It's quite a big difference with like a change, like a small change, like mean to median. So yeah, it's good to explore things like that. But yeah, cool. The last thing I was going to say is that we're going to apply for a DeFi, a grant from Algovera Grants for the DeFi project, which would mean that we can start to like pay contributors and stuff. Because at the moment, like Vintage is doing this in his spare time out of the goodness of his heart. So it would be nice if we had a treasury to start paying people to work on this. I think that would be great. So I'm working on a draft of that with Christian, Iago, and Greg. And so we'll probably post that in the next few days. And then, yeah, see what the community decides on voting for it. But we have some good numbers in this group. So hopefully it has a good chance of getting through. But yeah, the other thing is like, it would be great to start working on the windowing approach. And so maybe I can like, maybe me, Jakob, and Vintage can kind of, and Iago as well, if you're interested, can organize on that during the week and see if we can, it would be great to come up with, to get that fixed. And then we can really quickly run experiments on, you know, just on one time series or maybe on multiple time series. And so once we've set that up, we can very, very quickly start to like get through different experiments to see, you know, our other protocols influencing it and stuff like that. Yeah, so maybe we can hack on that async and catch up on it next week or something.
Sure.
Yeah, sounds good. And like, if you guys ever want or need more data, just like at me in the channel. I can kind of, for now, just be like the plumber, the data plumber for this.
I think it would be helpful if we had the like both data sets block by block, if that's possible. Then I think it would be,
for the same, like, do we want to focus on, I mean, we can talk about some channel, but we can pick like a subset of tokens as well, or we can just go with the same ones.
I would like to see stable coins. Not sure if you guys agree, but I think that's where the borrowing activities is higher. So
okay, yeah, USDT, and DAI. Stick with that.
Yeah.
Well, wouldn't ETH tell you? Because you, like you were saying, people would deposit ETH and then borrow. So I feel like ETH's a good asset to just keep.
Okay,
sure.
And maybe, yeah, I think ETH's fine. It's the ETH ecosystem. It's not Bitcoin. So
Yeah, you're right.
and it's not even Bitcoin. It's wrapped Bitcoin. So
also, one small note is that you can deposit ETH into Aave, but you can't deposit ETH into Compound. I think, right? It has to be wrapped Ether. But
I'm not sure.
Yeah, we can double check on that.
Yeah, and it's also interesting to take some qualitative analysis. Like, for example, when you deposit USDT onto Aave, you can use it as a collateral. So the rates, they will pay you more than the other ones because you can't use it collateral. So this type of analysis is also important to keep track of, so we don't get a misunderstanding results or anything.
they also, I just know about Aave, but they have like a scorecard of how they rate their assets. So there's different, I guess, percentage that you're allowed to deposit or you're allowed to borrow against because it's over collateralized. So that's just also another aspect to think about as to why people are taking out or depositing certain assets.
Yes.
Yeah, and that's actually, I think, determined, well, it's determined by Gauntlet, which like is a risk scoring company for DeFi, I guess. But I think also governance votes on that too. So that's where that comes in, like off-chain stuff influencing that.
Great.
Cool. All right. Great. I'll chat to you in the channel then in next week. And yeah, let's keep the conversation going and keep hacking. It's looking good.
Thank you very much, guys. See you next
Cool.
week.
Thanks, everyone.
Thanks, everyone.